I think it's probably obvious you guys should just be in class. I'm pretty. Hit record sometime. So a density curve, and this is on here that says density curve in bold. A density curve is a curve that is always on or above the horizontal axis and has an area under 1 underneath it. You will get, I have seen some strange questions on the AP exam, or not strange, that are so simplified that I want to very briefly mention it. If I tell you this is a density curve, and that means this area has to be 1. If this is 0, the basic one first. If this is a square, and it goes from 0 to 1, and this has to be an area of 1, what does it go up to? That basic. So if this is 2, what would this be? And I could do all kinds of math. I could even do something like, why is it happening? This times this has to equal 1. Would be what? Because from here to here is 3, so 3 times what equals 1/2, or equals 1, so it's 1/3. I've seen some basic stuff like that. I'm not going to get too into that right now, but technically that can come up, and I have seen it a couple times. The median of a density curve is where half are underneath and half are above. That makes sense. That's exactly like the definition. I'm not going to talk about this part too much. The mean is technically like if I were to like physically have a curve and set it on top of my finger, where I could balance it to where it wouldn't fall over one way or the other, is where the mean is. Like that's physically how it works with density curves. So like if I have an outlier way over there, where am I now going to have to balance my finger a little bit? More over that way. So like that idea makes sense. That's that same thing we were talking about yesterday, is like the mean gets pulled down that curve. Well, if I have something out here, I'm going to have to move my finger this way a little bit to balance it out. So any probability curve is technically a density curve. We don't get to it too much as far as our class. Bottom left says normal distribution. This is going to be the really, really important thing for the majority of our entire class, is a normal distribution. So it is a density curve. It is symmetric. It is unimodal. It is bell-shaped. And all normal distributions have the exact same shape. The mean of a normal curve is the mean of a distribution. The standard deviation is a standard deviation. Don't worry about that part right now. I just need you to see that if I write something like this, I mean normal distribution. We'll come back to that. Let's do this in, I didn't save you a whole lot of room here. So in this gap, we're going to draw a normal distribution. What are some things? Can you tell me anything that you noticed about the way I drew that? That I did or didn't do? No labels. What else? I drew it very specific at a certain point. What do you notice that my graph doesn't do? Doesn't touch what? So why? Let's say it is something like height. Is there a point in which someone's height physically can't, like, is there a cutoff where as high as somebody can be?
Yes.
Or probably higher.
That was probably like 0. But it goes really, 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 really far that way. So there's not like it all of a sudden just closes. So the probability gets less and less and less likely to where it gets super, super close, but it keeps going. So that's just something I want you to notice about that. Try to get in the habit of not touching them, just so that you understand that it does keep going outside of what we're drawing up here. All right, so it is symmetrical. So this is the what of the graph? Mean. Don't write anything. What is that? What is that? What kind of mean? I mentioned it yesterday. Somebody said it. Sample mean. What is this?
Standard deviation.
Of what kind of standard deviation?
Sample standard deviation.
Technically, this symbol is population mean. This symbol is population standard deviation. I am not going to be picky right now until we need to talk about it. So I'm going to write these because these are the ones we were talking about, even though technically I should be writing these. So I'm writing mean and standard deviation. I should technically be writing these. So like I think somewhere in your notes, like you'll see these symbols instead. Yes, I should be using those, but I don't want to make that a confusion point right now. So right here is the what of our data you said? So that's where my mean goes. And what we deal with is like rings, the target rings. We essentially deal with, we label 3 target rings. So that would be 3 away, whether it's to the right, equally spaced, hopefully, and 3 to the left, again, hopefully, fairly equally spaced.
And these are what you said?
What are those? I didn't tell you. They're what?
Standard deviation.
Standard deviation. So like the rings that I talked about in a target are like a standard deviation. So these are representing, I moved 1 standard deviation, I moved another standard deviation. So math kind of equation type thing, what can I write in symbols that this line represents?
That's the 1s, 2s.
Now is it just 1s?
Or it's mean plus s.
So that's my mean plus 1 standard deviation. This would be my mean plus 2 standard deviations. Mean plus 3 standard deviations. So what would it be going the other way? Minus. You're not going to be able to read that, but you'll know what you're writing there. Alright, so what percent, don't draw this, what percent of the graph is there? 50. What percent of the graph is not there? 50. For every normal curve, there are 3 numbers that approximately fit. Don't draw this on here because it's going to be a lot. There to there is about 68%. You're going to draw different numbers, so just don't draw that on there. So on your sheet, you have a bullet point. What does it say above that first bullet point? 68% of the data fall within what? 1 standard deviation of the mean. And we can sit there and write out that whole sentence again, but then it skips to 95% are within 2. I'm gonna put these here again. And then it even says this on the top of your sheet, I think. It just says 68, 95, 99.7 roll. Now, I chose to put this on a completely separate paper than the one we did before for a very specific reason.
Wait, so the percent's not have to go over here.
I'll show you what I mean about in a second. I mean, good question, but I'll show you why it does that. And it says empirical rule up here. Doesn't it say empirical? Okay. So only if we know the distribution is normal does this apply. Because if we have something that all of a sudden looks crazy like this, is that same percentage breakdown going to work? No. Alright, so let's come back to this picture here. So if 68% is between here and here, the left side and right side are symmetrical. So what percent is in this section right here? Which means 34 is also here. Now, if you memorize 68, 95, 99.7, which you will pretty quick, you'll memorize this whole graph. We're breaking down this whole graph based off of those three numbers. So between here and here is 95%, but how much have I already used?
68.
So how much is left? What do I do? 27 divided by 2, so that's between 3 away is how much? 99.7. We've already used 95. How much is left? And divide by 2 gives me. So back to your question of not equal to 100%,
Yeah, that makes sense.
because it can happen outside of there. So this is where somebody being super, super short can happen, but it gets really, really, really unlikely. So how much is left outside of 99.7?
23.
So this is
20.
This is a ginormous concept for our class. The math behind what we're doing today and figuring out and answering these kind of questions is actually really easy. If you can be with me to get to there. Let's go ahead, since I'm trying to do better about this. The back of our sheet, wherever we are. Let's go with empirical rule. All I want you to write is 68, 95, 99.7. And that should already make enough sense to you, but we'll do this enough to where that'll definitely make sense to you. The one thing I want you to write other than that is what? Only for normal. And these are all estimations when we're using empirical rule. So it's not perfect, but it gives us a good guess. All right, so our example problem gives a gap underneath it. It says, heights of young women aged 18 to 24 is approximately normal with mean of, and so there I have mu. If you want to mark that out for the X bar so you don't get confused, I'm fine with it. And it says sigma, squirrely looking circle instead of the S. If you want to put S there, that's fine. So I am using this curve again. How many do I go each way? So 3 vertical lines each way. I'm going to fill in my percents. My 2 closest ones are what? My next 2 are what? Are these numbers ever going to change? No. My next 2.
1.3.
And then my last one's 0.15%. And don't write anything on the bottom yet. So this one gives us mean and standard deviation. So instead of writing things like x bar and x bar plus, we're actually going to plug in numbers. So the first number I'm going to write down is what? Like physically, which number? Which of those numbers do I start with? Mean. Where do I write it? So this is just a number line. My number line is centered at 64.5. In order to find what number goes here, I'm doing what? Adding 1 standard deviation, which is 2.5, so it gives me 60 what? 67. My next one is and the last one,
Wait, how do you find that?
all I'm doing is plus 2.5 each time I do that. And for your notes, since this is your notes, it's probably not a bad idea to write so that you're telling yourself where you got that. And my last one is what? So when I go left instead, I'm doing what? So the next one is then, and my last one, now I am going to draw on the board and shade for each A, B, C, and D because I can erase. Don't draw on top of your graph. Like, you're going to be okay with looking at it. So this says between what heights do 99.7% of the women fall? Well, we know 99.7 is within what? The 3 standard deviations. So my answer there is what?
7 and 72 inches.
B says what percent of women are shorter than 62? So you're not going to physically do this, but mentally you're thinking, here's my line for 62. I'm shading all of this and adding it up. What does that give you?
15%.
99.7. We did this one wrong. What should that be? Should be 2. That's a big thing everybody needs to see. That was 99.7, which means that was 4.7. 4.7 divided by 2 is 2.35. Which means the answer to B is what? What's even easier than adding these three together? What is half of the graph? 50, but I don't want this part, so 50 minus 34. I would think it would be easier there. Part C, what percent of the women are taller than 69.5? You're just taking this and adding, which gives you what? And what percentile? So what does percentile mean? Everything less than that. So percentile always means what I call shade left. It's always less than. So from here all the way to here, well, what's from here to the left? 50. But I also want this much, so it's going to be 84. Questions on that? So it's a huge concept, but the process of me giving you a problem and asking you to solve for any of the pieces is basic math and should be easy. Let's go back to homework now.
Is this